My name's Andrew. I'm the head of customer success at a company called Seldon. I see some faces that have already come over to the booth, so thanks for the chats today. This will be a pretty practical hands-on workshop where I'll showcase more the usage of Seldon as opposed to the full installation of it. So you can see it more from a data scientist, machine learning engineer perspective, how you actually go about deploying your models and monitoring them. So I imagine there's some familiarity with Kubernetes in the room, and maybe some people have also used Seldon already, but I'll provide the high-level overview, and I'll sort of be jumping back and forth between slides and then also a Jupyter notebook, so it's sort of a bit more real for you. So yeah, thanks for coming. So this is roughly what we'll work through. So as a data scientist, your model is good to go. Now you actually have to deploy it. That's what we'll be discussing. So we'll talk about the serving aspect of that, and then we'll move into the monitoring aspect, and then just some sort of key takeaways of how Seldon can help you across your organization. Just so you know, this is all going to be based on open source technology, and I'll make the notebook available afterwards. So all of this you should just be able to run yourself, as long as you have a Kubernetes cluster up and running. Cool. Okay, so just getting started as a data scientist, your job, obviously, you're grabbing labeled data, you're then cleaning it up, you're experimenting across different frameworks, you're then picking your best model, and then you're ready to deploy it. So you kind of throw it over the fence to the MLOps team, and you say, okay, great, make me an endpoint so that we can start incorporating this into our application. So for this particular workshop, we'll be working through a real-life example of a crack detection use case. So you can imagine on an assembly line, you might have machine vision use case like this, where you're trying to understand if there are any defects, perhaps if you're assembling cars or really anything else. So we'll be leveraging PyTorch for this and doing some transfer learning. And then, of course, the requirements here, a large enterprise, a big manufacturing company, you need extremely low latency, very high throughput. So we want to be running this on infrastructure and a server that can handle those requirements. But then we also want visibility into how the model is actually performing. So at this point, there's a few different paths you can take. I'm sure a lot of people in this room have already used a lot of these tools. So the first thing, simple thing, might be to just try and wrap that up yourself. Maybe you just create a little Flask wrapper, a fast API, and then you try and deploy that yourself. You get your Docker container and put it onto Amazon ECS, and you have an endpoint. Maybe you're using some serverless functionality. I mean, that's great. I think that works for very simple deployments if you don't need too much more monitoring, and that can be a good solution. The second option is to just use one of these end-to-end platforms. So there's lots of platforms out there. Some of them are specific to the clouds that you might be working on, and this will help you all the way through your training and experimentation, all the way through to deployment. But all of them work slightly differently. They all have their own nuances, limitations. I mean, there's benefit, I think, to having an end-to-end approach, but there might also be more benefit to having the flexibility to just use a framework across essentially any cloud that you want, and to be able to deploy your models in a very consistent way on top of your own infrastructure. And for that, I'll be sort of proposing using the Seldon set of tools here. So Seldon Core, we'll walk through in a moment. We'll walk through the different servers that you can use to deploy your model. Just to note, everything, Seldon is a very Kubernetes-centric company, so essentially all the tools we have work very well within a Kubernetes cluster. And then we'll use a Prometheus database to actually start logging some metrics, and then throw a Grafana dashboard on top. Cool, so let's jump in then. So to start with the serving side of things, Seldon supports a couple different servers. So the first one is called ML Server. ML Server is a homegrown serving solution that works really well with either it's a custom Python wrapper, or it's a lot of these types of frameworks like XGBoost, scikit-learn, like GBM, MLflow, etc. So we found that was sort of missing in the market to some degree, so we just built it ourselves. But we also support, obviously, the best serving inference servers in the industry with NVIDIA's Triton server. And so what we've done is we've actually had a industry collaboration across with NVIDIA, with the Kserve project, and with Onyx to come up with a protocol that works well across all of these different servers. So you could, for example, have an ML server preprocessor that then feeds into your PyTorch model, and then maybe there's a little post-processor. So today we'll be using both of these actually, but we'll focus on NVIDIA since we're using a PyTorch model. Servers, so you can put as many models onto the servers as you like. and then you can construct these pipelines around the servers. So we'll just walk through those quickly now. So like I said, this presentation won't focus as much on the installation aspects, but it's all in the documentation. You can get up and running pretty quickly. And if people are interested, we can always do deep dives into the actual architecture of Core V2, perhaps in another talk. So before I go any further, what I'll actually do is just hop over to the notebook, and we'll start the first piece of this, since maybe it's less relevant for the talk. It's more the training side of things. So let's get through this fairly, which is serving and monitoring. So this notebook, as you can see here, we're going to focus on loading up the crack detection data set. We're going to do some transfer learning. We're then going to create a preprocessor. And then we're going to configure all of these so that they're ready to deploy with Triton. I'm not sure if most people in the room have had experience with Triton before, but there's sort of some nuances there. We'll test it all locally, and then we'll get the model ready to serve in your Kubernetes cluster by actually taking those model artifacts and putting them into bucket storage. We'll then obviously deploy everything and have a discussion around monitoring. So of course, first things first, just create Conda environment, install your dependencies. I'm not using anything too crazy here. And then the next thing is I just have a data set that I've put in my own bucket storage here, so just download that data set. I won't do that now. It's a bit risky on the Wi-Fi. So now we'll get going. So we'll define these couple classes. By the way, can people see this? Should I zoom in? Maybe a little bit. Okay, is that better, hopefully? Okay. All right, so the next step here is I'm basically just going to load up the data. So just create some data loaders here. And then from here, I've created this little function to do some transfer learning. So I'm just using a ResNet 50 model, and then I'm just removing the last few layers, and then I'm retraining them on the crack detection data set. So again, I'm actually not going to run this because it'll take a little while, but here we have a crack detection model that is ready to go. I'm sure most people in this room could probably do better, but that's not the point of this workshop. So next thing is I'm going to build a separate pre-processing component for this model. So just to showcase sort of the power of pipelines and how you could have a separate preprocessor that maybe you use across lots of different models, and then really you're just switching out the model weights as you're iterating on the main model. But also, yeah, opens up lots of flexibility there. So I have a little preprocessor module that I've created. Doesn't do anything too wild, just resizes things and normalizes it. Center crops. And from here, just locally, I can start playing around with my model and seeing how it works. So hold on a sec. Yeah, that's great, isn't it? Very interesting. Hold on a second. I'm just going to rerun some things. This is classic, isn't it? My God. Okay. Right, we'll just import these things. Okay. Set up our preprocessor. Oh, that's so interesting. Okay. Well, let's continue on anyway. Essentially, it's just predicting whether there's a crack or not. So we'll now move on to the actual Triton configuration here. So for Triton, it's an inference server from NVIDIA. It's really good on top of GPUs, obviously. It's really great for deep learning and anything that you want to deploy there. So using PyTorch, of course, we'll be using NVIDIA Triton Inference Server. So the first thing I'm going to do is just create a little directory for my models. And then the next thing we want to do is to actually use, here, hold on a sec. Blend this one. Okay, here we go. Let's load the model up. Okay, there you go. It's all working now. Cool, so there's your prediction. This one's normal. We could run another one. This one seems to be a crack. Okay, so over here, all I'm doing is I'm just using Torch script to actually serialize this model and then have it available for deployment. So this is just a model.pt file. The next thing that Triton's going to expect is a config file called config.pbtxt that sits next to your model artifact in bucket storage. And for this, you just have to define something. So the name of the model, obviously, the platform. So Triton has a bunch of different backends. So you could use DALL-E, you could use TensorFlow. You could even use something like TensorRT. And specifically, I think TensorRT LLMs will supersede what's called Faster Transformer, which is sort of their framework right now for deploying LLMs. So of course, this will be very relevant once they come out with TensorRT LLM and make that GA. But for now, we'll just use PyTorch here, and I'm going to define essentially what the input looks like, so the shape of that input, the batch dimension is assumed, data type, and then the output and the output name. And I'll just be running this on CPU, so it will be fairly slow, but obviously the idea is that you would be deploying this on top of a GPU. Okay, so next I'll serialize the preprocessor as well in a very similar fashion and create similarly this config.pbtxt. So we have the image coming in, and then the output would be the preprocessed image that obviously then feeds into the main model. Okay, so now that I have this all locally and it's all serialized and I have my config files, I can actually go ahead and just run this command locally to spin up an instance of Triton right here. So let's see if this works. Very interesting. Okay. I think I know why that is, because if I look closely, I think this has models. Yeah, okay, I see why. Yeah, that should work. Just the wrong folder name. Yeah. Okay, so everything's loaded up now. So my preprocessor is loaded into Triton, and my model is loaded into Triton. So that's running in the background. Whoa, there's crazy stuff going on. Not used to working this zoomed in. So now I should be able to actually just run some requests to these local models. So I'm going to load up a little image here. I'm just going to do some light transformation on the client side. And then the key thing here is I'm actually converting this into what's called the Open Inference Protocol. So this is what I was describing a little bit earlier, which is sort of that standard that was set across Seldon and across NVIDIA. And I'll show you what the structure of this request actually looks like. If this comes through. Okay, so essentially it's just a list of objects here, and each object is considered an input. That input has a name, it has a data type, it has a shape, and then it has a tensor. And this is just the structure that's expected by this model. But the cool thing is we actually, through ML Server, we have a number of little utility helper functions here. So I'm using what's called the NumPy codec. And what this enables me to do is to just take a NumPy array and then just automatically create this Open Inference Protocol request. So you don't have to manually do that yourself. Okay. All right, so I'm just going to create a small function here. This is just for the purpose of making requests. So nothing too crazy. And now I can use this and send a local request. So this is just testing Triton locally on my machine. Obviously, you want to make sure that the one that you'll be deploying in production is the same as what you're using locally. But so far, it looks like this preprocessor worked pretty well. And from here, I'm just going to take the output of the preprocessor, convert it into a new request, and then run a request to the actual model, which should then define whether or not this was normal or a crack. So looks like that all worked, which is good. So now I can just shut that down. And the next thing is obviously to start deploying the model. So Core V2 we discussed briefly. I'm just going to jump back to the slides and walk through the different custom resource definitions that we have available. So firstly, there's the server. So like I said, it's either ML server or it's a Triton Inference Server. And we have a very simple server definition here. And you can override anything that you want. And then there's a much larger server config in which you'll define everything in terms of the resources that you want to be using, in terms of whether it's sitting on top of a GPU or a CPU. There's lots of things that can be defined. You can think of this as almost like a template for your server. And then from there, you can just create a very simple server, and essentially all you need to specify is the server config. But then you could also override that. Maybe there's a different image that you want to use for your server, for example. So just jumping back, I'm going to create this very simple server here. So you'll see it's just a server resource here. I'm just using the server config that comes standard with Seldon, Triton server. And I can even jump over to, this is just K9, so this is going to be my Kubernetes cluster. And I'll just go to the different servers that I have available, and you'll see that I've deployed a few servers here. So this Triton server is the one that we'll be using. Okay, so you just use kubectl, apply, and create that server. So the next thing we're going to do is actually deploy a model and put the model onto the server. So for that, we have a very simple custom resource definition called a model. And all you have to do with the model is just point towards the URI of where you've taken your model artifacts and put them into bucket storage. And then you can also specify, secret, of course, on that model as well. So one of the things just to note here is you see this requirements section. This is a bit confusingly named because this has nothing to do with sort of your pip packages or anything like that. It's actually just a tag on the model. And then on the server, there's a set of capabilities, as we call them. So over here, you'll see this set of capabilities, which are just tags. So you could say something like requirement GPU, and maybe you've deployed a server that has a special capability that's GPU. So you know that model will be loaded onto the GPU server. Cool, so I'll jump back here into the code. And a good rule of thumb for creating these models is to figure out essentially how big they are, and then that's how much memory we would expect them to consume. So I'll create a model manifest for the crack detection preprocessor. And then I can essentially just deploy that. And then similarly, I'll create one for the crack detection model and then deploy that model. And so now we can list all of the models that we have available. So I'm just using kubectl to get this models resource, and you can see I have a few other things listed. But the other cool thing is Seldon Core v2 ships with the CLI. That makes it really easy to interact with Seldon. So you can load and unload models, you can deploy new servers or construct pipelines or trace sort of how things are moving through pipelines. So here are all the models, and they're good to go. Just shifting back, we'll now talk about pipelines. So pipelines are a really easy way to just construct these more complex workflows. So here's a very simple example of what we'll do today, where I'm going to have the preprocessor feeding into the ML model, and that will all run very synchronously. But then later on, we'll also deploy a drift detector. And that drift detector will just receive these requests asynchronously up until it gets to some certain batch size, and then from there, it will trigger the drift detector. And then you can use that as part of your monitoring. The final resource here is just called experiments. So experiments are more for A/B testing and progressive rollouts. So maybe you want to do a canary deployment where you're splitting the traffic 50-50, to one model and another, or you can do what are called shadow deployments, in which all of the traffic will be fed to both models, but only responses will come from the primary model. So you can also just monitor those in production until you're ready to promote the challenger model to be the main production model. Okay, so here's the very simple pipeline here. This is without the drift detector. You'll see, it's fairly self-explanatory in terms of the steps here. There's a preprocessor, and then there's a model, and the input to the actual model is the preprocessor model, and then the outputs are just from the main model. So I can then deploy this, and I can use the CLI here to list all the different pipelines that I have available. And then from there, everything should be up and running. So I should be able to start doing testing on my actual model that is now deployed in production. So yeah, I'm doing a few things here just to grab the IP of the ingress here, and then I'm setting a couple headers. So, this is all in the docs, but essentially just specifying the name of the pipeline. You can also make requests directly to the model, and then that could improve inference speed as well. And then we're just specifying the namespace here in the header. So from here, I can hopefully make a request to the model that's actually sitting in my Kubernetes cluster and get the same response. So what's great about this is you can see here we're getting, okay, this is a crack on this particular example, but this is now run through the whole pipeline. So it's run through the preprocessor, then into the model, and it's now feeding back the response. Cool, so that's deployment, at least on top of Triton. Are there any questions so far, just on the deployment side of things?
Resource types like server, pipeline,
Yeah, yeah. So that's essentially what Seldon Core is in a nutshell, is a set of custom resource definitions that help you spin up all the lower level resources. So when you deploy a server, it'll construct that pod and put everything all the different containers that you need into that server. And then when you deploy a model, it's basically just telling the agent that's sitting in the server to load that model up into the server. Yeah. Mm-hmm.
How does that integrate with MLflow? Do you just give it the endpoint of the model? How simple is that?
So ML Server actually has an integration with MLflow, and I've chatted with people at MLflow too. They do use ML Server sometimes as well to just deploy their models. I mean, basically, are you saying because MLflow supports like all the different frameworks underneath as well, essentially, MLflow is an experimentation framework for the most part. And then once you have your final model artifacts, that's just sort of put in a structured way into a folder. I think it has like an ML model file or something like that specifies the backends and some of the dependencies. And so ML Server will know what to do with that model because it's an MLflow model, and it will install all of the dependencies automatically into an environment. So yeah, there's a few different ways to think about how to manage environments in Seldon. Yep.
In your pipeline, you have a preprocessor. Is there any post-processing capabilities? So typically with recommendation systems, you have post-processing to filter out any information, etc.
Yeah. I mean, the pipelines can be as complex as you want. So you could basically, put as many different models into a pipeline as you like. So definitely, post-processing is something that a lot of our customers do. All right, next I'm going to move on to advanced monitoring. So I'm calling this advanced because we're going to do a little bit of drift detection as well, which maybe you don't typically do within your monitoring stack. It can be quite complicated for various reasons. But we'll start out at the very high level. We'll just talk about standard monitoring. You can think of these as just operational metrics. So ML Server and Triton are both very standard in the way that they're exposing metrics on port 8002. So we can set up these pod monitors and scrape all of those metrics and then put them into a Prometheus database. So Prometheus is sort of very native to the Kubernetes ecosystem. It's used for time series metrics, and then we'll throw a Grafana dashboard on top to visualize some of those metrics. Okay, so let's move on to that then. So just to start out, I'll just showcase that, on this Triton pod that I'm using, I can actually, just port forward this 8002. And then I can just make a little request and see what's there. So you can see that obviously, some of these metrics are already there. And this is what we're going to be scraping and putting into Prometheus. Okay, so just to showcase this and make it a little bit more real, we'll set up a Grafana dashboard. So the first thing that you would need to do is just create a service on top of Prometheus so that Grafana can talk to that service. I mean, don't need to go into this too much, but we'll create the service. And then next, we'll set up Grafana. So I'll create a Grafana namespace in my Kubernetes cluster. And then from there, just install Grafana. So here's Grafana. I'll just pull the latest image of that, and then I can apply that. Maybe I'll just leave it for now, because I think it's the same. Okay, so now to actually use Grafana, I'm going to port forward. Okay, so now I should be able to just navigate over to this local-host and see Grafana that's sitting on top of Prometheus that has been scraping metrics. Seldon actually comes with some dashboards that you can just install automatically. So I'm just using one of the pre-packaged ones here. I'll pick the right namespace, obviously. So I'll go to the Seldon namespace, and you can see already we're getting some metrics in here. So we can see how many models are loaded into Triton at the moment, how many models are loaded into this custom server that I built, as well as the standard ML server. And then, well, we haven't even spoken about some of the more advanced core features. This may be not the point of this talk as much, but there's some details about sort of loading and unloading of models. And then, of course, just your basic CPU, memory, etc. So that's all here. Cool, so I'll shut this down. Yeah, I suppose you could run some inference requests and actually see the dashboard and working. If you want, you can also just go straight to Prometheus and check out some of the metrics there. So I'll just port forward this. And then go to Prometheus directly. And then within Prometheus, I mean, it's already scraping all kinds of stuff. So it's not just scraping all of those model metrics and server metrics. It's scraping everything in your Kubernetes cluster. So you can, really just use this as best practice. Okay, so that's more just the basic monitoring side of things. You can get some standard metrics, but Seldon makes it fairly easy to do that. And next, we're going to dive into creating and deploying a drift detector. Any questions on the Prometheus Grafana stuff? Yeah.
Does this ML server have any other endpoints defined apart of inference and methods, maybe something else, metadata?
Yeah. I think as part of the open inference standard that we've created, there's several different endpoints. So there's infer, but then there's also ways to get metadata about your model, to check the health of your model. And there might be a couple others as well.
Is there a limit to define custom?
That's a good question. I don't think so. Yeah.
I was wondering, what metrics do you use to scale the pods using the HPA?
Yeah, so in Seldon Core V1, we leverage HPA sometimes, so horizontal pod autoscaling. And for that, you can use really any of those metrics that I just mentioned. So maybe it's memory usage, it could be latency. You can set sort of tolerances on those, so any metric effectively. But then you could also upgrade and start using some other tools as well that allow you to use, say, for example, latency in your Kafka pipelines, or sort of other metrics that you might not normally use. So there's different ways to set up HPA. But then in Seldon Core V2, we think about scaling a little bit differently than in Core V1. So not to get into too many details, but in Core V1, typically there's a server, and then there's one model within that server. Whereas in Core V2, those things are separated. So you can have a server, and then you can load as many models as you want into the server. So it's more about when do you sort of create more replicas of your model versus when do you vertically scale your actual servers versus when do you horizontally scale those servers. And we have, in Core V2, there's a number of different tools available for auto scaling. All right, we'll move on to drift detection. All right. Cool. So drift detection, I mean, sort of buzzword sometimes. Everyone's very excited about it. It's hard to do, though. It's difficult to actually incorporate a drift detector as part of your full production machine learning pipeline. But what it's really doing for you is, in absence of ground truth labels, you're not able to see the accuracy of your model. But you do still want to understand, is the performance of my model degrading? And so you can sort of use a proxy for that, in a sense, by looking at, say, a reference data set that your model was trained on, and then using some statistical techniques to basically do some tests and understand, is this input data diverging significantly from the original data that it was trained on. So in this crack detection use case, you might imagine, someone bumped the camera and now it's like looking at something else, or maybe it's got a little smudge on the screen, and you would never really know that unless you had some sort of drift detection capability. So this is where you have all your labels, but in actuality, this is more what the data looks like. So we need some ways to sort of approximate whether your model performance is changing. There's lots of different drift detectors, obviously. Seldon actually has a library called Alibi Detect, which has a number of production-grade drift detectors. So we'll be using some of those today. Let's dive into that then. So we'll be using an MMD drift detector. So I'm just going to use Alibi Detect, and I'm going to import this MMD drift class. Now, all I'm doing here looks crazy, but is basically just getting a reference data set that I can use with my drift detector. So here's my reference data set as a NumPy array. And now I can create this drift detector. So I'll use PyTorch on the back end, and then I'll set some tolerance here for my p-value for when drift has occurred. And next I can just serialize this, save this drift detector, and from here, locally you can just sort of test it. So I'll load it back up. We'll take a little prediction on a small reference set of data here. So just a couple examples to see if drift has occurred. looks like it hasn't, but you also get your p-value back here. And you can go and investigate all the other drift detectors we have. This is working more in batch, whereas other drift detectors work more on a feature-by-feature level. There's other techniques you can use to sort of do some dimensionality reduction, potentially, before you feed this into your drift detector. But all of that is very configurable when you're using pipelines. So yeah, so now I'm just going to push this drift detector over to bucket storage and then see how big it is. It's tiny. And then I'm going to deploy this just as a regular model. So the key thing here is the requirement that I'm specifying is a tag that's on the ML server. So we already have a runtime to load up these drift detection models. Cool, so now we can just apply this and we can list all the models and we should have our drift detector available. Yep, so that's available. And from here, let's see, I don't know if I got this far in my code, but yeah, basically, the next thing to do is to add this to your pipeline. So we can use the exact same pipeline, the same pipeline name. The only difference here is that now we have this new model, crack detection drift detector, that takes as input the crack detection model. So there's different ways to configure this, really. So this is taking the output of the model. So it's taking the softmax layer, which softmax layer is sort of a lot of the features compressed, obviously, but maybe the ideal case is you're using some earlier layers of the model to get sort of some features, but also do some dimensionality reduction. But you can configure this in different ways. I mean, you could also have this feed in, say, for example, from the preprocessor. So maybe I'll try that, see if that works. All right. Yeah, so from here, I can see that my pipeline's ready, and then from here I just make requests to my model as normal, nothing changes. The only difference is that asynchronously all those requests are being loaded up into that drift detector, and it's actually using Kafka on the back end. So with Kafka, you can build sort of a Kafka consumer, maybe you configure a Prometheus alert on top of that. And yeah, so that's drift detection. And then some other monitoring pieces that we haven't really covered yet here is inference logging. Weird. Inference logging makes it very easy to hook up to, say, Elasticsearch or something along those lines. So it pairs all of your requests and your responses and pushes it to the database, so you can feed that back into your training data pipeline. And then microservice tracing. Tracing is more for the pipeline, seeing sort of the how the request flows through the different components of Core V2, but then also through the different models and understanding where there might be latency. And then log scraping is maybe something that you want to do as well, just in general, so you can monitor all the different API requests. Okay, so that's the more practical side of the presentation. Just a couple quick notes to end on here. So firstly, one of the differentiators about Seldon is that it's all open source. So you could have as much flexibility as you want on the training side of things. And then Seldon purely focuses on the deployment side, meaning that you have lots of control over your deployment infrastructure. Another quick note, obviously it's cloud agnostic because all you're going to need is just a Kubernetes cluster. So you're not locked into any particular cloud provider. So it's great. Data scientists can use the tools that they want to use. MLOps engineers can configure their infrastructure how they want and use things like Terraform and just sort of spin up, new Kubernetes clusters with everything built in. And so there's lots of flexibility in terms of how you use it. And then, sort of more on the business side of things. Obviously, you're going to get models to market a lot quicker. You're using a framework that's tried and true. It's tested. It's got a big open source community. You don't have to build it from scratch. And then I think a big thing is when you're running it on your own infrastructure and you're doing things like GPU sharing, you can actually start saving a lot of money because you're not using, say, a serverless endpoint or, say, a Vertex endpoint or something like that. And then obviously with all of the logging and the monitoring mixed in, you might be mitigating some risks. So in general, there's lots of different reasons to use Seldon, but it's one of the many options for model deployment and monitoring. But yeah, I would encourage anyone to pick it up and give it a try. So that's it from me. Probably rushed through pretty quickly, but are there any questions?
Are there large language model specific features like quantization, adapter, LoRa adapter, flash attention built into Seldon Core ML server?
So it's a good question. I mean, I'll try and answer and then maybe hand over to Josh, who's sort of focused on LLMs at Seldon. The answer is it's sort of a mix. I mean, something like quantization, maybe you do that at an earlier step. And then when you actually deploy the model, there's all sorts of techniques that some of these new servers, these new runtimes are using. So we have things like deep speed, we have things like VLLM, faster transformer, TensorRT, and those are all optimized for actually serving these large language models using various techniques, like continuous batching and different scheduling techniques. So yeah, it's sort of dependent on the runtime. But those runtimes can work well with ML Server and Triton.
Yeah, and to add also, it's not just the on-prem, so it would be like the open source llamas, Falcons, and stuff, but we're also working through API-based, so we've seen a lot of customers using Azure's OpenAI, so we have full runtime mapping for that. And to the quantization point, we have actually been talking to some customers and looking into kind of the aspects, because you want to fine-tune the model in its natural state, but then when you want to deploy it, you definitely want to make it a little bit smaller. So we're definitely thinking about it as all this new space comes to be, and trying to see like who wants what and how they want to do it.
Yeah, I know Josh is working on lots of demos and boilerplate code to do basic things like Q&A. Maybe you want to build a RAG application. So how can you apply this sort of pipeline framework that we've proposed, where maybe various components of it might be your vector database. And so there's lots of thinking internally as to where we can apply Seldon and where maybe we just use other tools. But yeah, we're obviously focused on LLM serving. Yeah?
Is the idea behind the pipeline that you would use it for something like conditional branching and ensemble models or something like that? Or?
Yeah. The example I showed was probably the most basic example of pipelines. And then there are different methods that you can use to either, maybe there's a trigger that then routes the model or the request to a different type of model. There are combiners that maybe you send a request to lots of different models and then combine the results in a final model. There's lots of flexibility there.
It's all the pipeline CRD.
Yeah, exactly.
So assume, this is very nice, but assuming that you already have a service, and that is a 12-factor app that you scale, that you handle parallelism, all the request SLA, monitoring, logging, and so on. Where is then the benefit of adding a whole new infrastructure where you have to relearn all these things instead of plugging a library in your service? Because needs emerge, and as mentioned in the previous question, then you need branching in the pipeline, you need more control flow, and before you figure out what's going on, you are programming in YAML, and that tends to be a foot gun. So I wonder, in a sense, why is there the need of a full platform for inference serving if you already have for ML serving, if you already have a service?
Yeah, I'm sure most organizations have sort of built up different capabilities over time. And like you said, there's always new needs that will emerge. But what we tend to see is most of our customers are large blue chip companies, oftentimes in very highly regulated industries. And they have lots of different data science teams. And all those teams are sometimes like building up their own stack of deployment tools. So I think the first way I'd respond to your question is it's sort of it's a turnkey set of best practices that you can implement across every deployment in your entire organization. And all of those things that you might need to build around monitoring, around routing or ensemble modeling or handling LLM serving, whatever your needs are, you can use different aspects of Seldon. So there's you could use the most minimal setup of Seldon, which may even be just ML server, and then you deploy that on EC2. And that could be sort of starting to use some of the ecosystem. And then from there, I think you can just add based on what your needs are.
Is there a need to deploy Seldon service not in like a service way? I mean, for example, like Kubernetes job.
Could you explain a little bit more what you mean by a Kubernetes job?
Usually
Oh.
And not all the time is present by the microservice with this sort of resting points.
So sort of more of a batch type use case? Yeah, so Seldon is, I mean, we are primarily focused on real time, so we'll spin up the servers in the way that I just showcased, but then you can still use things like gRPC to run really fast. The servers are optimized for adaptive batching. We can obviously create more replicas of all of your models, all of your servers, so we can scale to handle massive batch workloads. But then what we've built on top is some batch capabilities that enable you to basically point towards a file that's sitting in bucket storage, and then we'll spin up, I think it's an Argo workflow that will break that down into multiple different smaller jobs, and then it will run it through the model and then push all the results back to bucket storage. So you can still run a batch workflow on top of a model deployed with Seldon. It's just, that's sort of how we do it.
Okay, so actually, between the pipeline steps, the data is passing via gRPC protocol.
Yeah. It's gRPC, and then at least with Core v2, it's also using Kafka. So Kafka is sort of a big part of the underlying infrastructure for using pipelines. Love it or hate it, that's sort of what we're using for Core v2 at the moment. Core v1, it doesn't rely on Kafka at all. For Core v1, yeah, we're using sort of slightly different techniques. Cool, yeah? What I'll do is push it to a repo. It's not right now. I'll push it to a public repo under Seldon's name. That's just called MLOps World, and then you can find it there.